Today we're solving addition equations that do not have the same order. We're going to make them into an equivalent equation, or think about the equivalent equation to remind ourselves about the solving process. Now, a property we'll be using to solve today is the commutative property. The commutative property says that values can be added in any order. An example of this in just numbers would be that 2 plus 3 gives the exact same answer as the other order 3 plus 2. So even though I change their order, I get the same result. If we're using algebra, you're going to see a letter. It's the same. However, x plus 2 and 2 plus x are equivalent. They are equal to each other. In our first example, we're not going to make any changes, but we'll think about what the equivalent equation might be. The equivalent equation would be to reorder. We'll show that in method 2. If I swap the order of the 4 plus x, just like in our example, it would be equal to x plus 4 equals 9. Now, I don't need to reorder. If I just solve with method 1, I'm going to try to make 4 into 0 so that x is by itself. In order to do that, I'm going to subtract, which is the same inverse operation as when we saw x plus 4. So I'll show minus 4 on both sides. Method 1 and method 2 are doing the same step. If I subtract on the left, I'm also subtracting on the right, and I'm going to finish the math for method 1. X is equal to 5. Just like before, we're going to check. I take my original equation, substitute in my answer, and make sure that both sides are equal. For method 2, my work is going to look very similar. Even though I change the equation, I should get the same answer because x only has one possible value. 5 plus 4 equals 9. I got the same answer, and both sides are equal. Now, equations have two sides that are equal. This is similar to the commutative property in that the left side and the right side can be swapped around. If you really want the x to be on the left side, you can take all of the things that used to be on the right-hand side, like in example 2, and move them to the left. So x plus 2 used to be on the right, and 7 used to be on the left. I'm taking both sides of the equation and swapping them. Our solution process is exactly the same though. I'm still going to subtract 2 to get x by itself. Hey, x equals 5 again. I do not need to change the order, just to check. Both sides should be equal. 7 is equal to 5 plus 2. Just like we've seen before, in addition problems, we're subtracting. X comes down. 7 minus 2 equals 5. Even though I changed the order, I got the exact same answer. That's because both sides were equal in the beginning, so when I change them, they should stay equal. If I use the commutative property to find equivalent equations, I'm swapping the two things that are being added. So for instance, x plus 3 here is changed from 3 plus x. The other side of the equation stays the same. However, if I want to swap the sides of the equation, I can do that as well. I'm going to take everything on the left and move it to the right. I'm going to take everything that was on the right and move it to the left. We'll use this to show what would happen if we did both. 7 equals 3 plus x. I already swapped both sides of the equation. Now I'm going to show the commutative property on the right-hand side only. We started with 3 plus x equals 7, and we were able to make 1, 2, 3 different equivalent equations.